that they work with, and then they're actually sponsoring next month's talk. So we'll have some sort of food or drinks for everybody
Awesome.
with that in mind. Huh?
Awesome.
Yeah, exactly. I was like, yes, we're more than happy to have you. Well, let's try again. Okay, I'll go through it manually. So, as I mentioned, in our space, the knowledge is ever expanding, and people that have knowledge have very specific domain knowledge, whether it's like web application security or network security or LLM security is a new space in cybersecurity. But all of these different specialties are unique and have unique considerations. And people that are experts, even if you're expert in one of these areas, you might be a complete novice in other areas of cybersecurity. And then there's a very limited talent pool, and everybody talks about how that in cybersecurity there's like 3 million unfilled jobs. But the truth of the matter is the reason that there's so many unfilled jobs, at least in part, is because it's not an entry-level profession. Basically, you need to have a lot of technical expertise before you're even qualified to work in cybersecurity. And so large language models are a huge help when dealing with that, but there are some challenges that we've had in building with LLMs, and I don't think those are unique to cybersecurity. They're challenges that pretty much all of y'all will have building with LLMs. So some of them are how that it's really expensive and there's really limited hardware. Like I heard this month that if you're looking for H100s, which is the like top of the line hardware that people like OpenAI are using, that basically they're booked out through Q1 of 2024 now. So like if you don't already own them, if you haven't already paid a deposit on them, and you're not like getting them off the back of a truck from somewhere, like you're pretty much out of luck until 2024. And I know I've tried using a number of like cloud hosted GPUs recently, and most of the sites that I go to, you can't get H100s. Most of the sites you can't even get A100s, which is like the next level down of commercial GPUs. So there's a really limited hardware, and that makes it challenging to build new products with it. There's also the concern of knowledge gaps and hallucinations. So these tools don't know everything, obviously, as we've already talked about, and on top of it, sometimes they'll just lie to you. And so trying to get confidence in the output of these tools is a big barrier to having users use them. Obviously, like if you work in a technical discipline, you know that how we build these tools, a big part of how to make these tools work properly is to abstract away from the user all of the challenges that you face in building it, right? Like, you know, I don't want the I don't want the user, so to speak, to see how the sausage is made. Like I want to serve them something that's going to make them delighted, that's going to make them really feel confident in using our platform. But when you have hallucinations or knowledge gaps, that undermines the user's confidence. You also have this big concern around latency, and that's a lot of what I'm going to talk about today, because latency is, like, in my opinion, the most urgent challenge, as well as like the challenge that's going to be with us the longest, because we are so hardware constrained, and because these models use massive amounts of data and massive amounts of compute. So it's pretty hard today. Have any of y'all ran a model on your laptop? Okay, yeah, so some of y'all have done it. It's really cool. You can get there's a tool out there called LM Studio that I've been playing with a lot this month, and it's just a piece of desktop software that will make it really easy for you to load and use these models on your local computer. Now, fair warning, a lot of the models don't fit on your local computer, and if you don't have a pretty high-powered laptop, then you're gonna have a really tough time. Like, it will use all of your compute resources, it will take up all of your memory, like, and it will be really slow. So that's not always true, but for a lot of the models, that's true. And then the final one is users aren't always well suited to give the models everything the models are looking for. So like as a user, you just want the answer to your question, and you have the question in your head, but the model doesn't know what's in your head, it only knows what you tell it. And so the whole process of like eliciting the information out of the model that you're looking for can be quite challenging. There are like three major deployment models that we considered. There's, using the APIs that are self-hosted by these various platforms like OpenAI. There's also kind of a big rush from AWS, Azure, and GCP to host things on your behalf. I've applied for, but haven't gotten access to AWS Bedrock, which is like their big play in this space. So I can't really speak to it. I have used Azure's OpenAI services, but it's essentially a replica of what OpenAI offers, just as a private instance. And then you have the third option, which is if you're really brave or you have a huge engineering team, is to build your own models and host them in a data center. But like I said, for I think all of us in the room here, this is probably not an option, at least not till Q2 2024, right? Like, and then when you're using these models, there's like trade-offs. So the third-party APIs, they just work, and that's awesome. But you're paying every time you use them, every request you send. That's not ideal. So there's the consideration of using open source models, and in this case, you're paying just for the GPUs, right? Like, it's a variable cost because you pay for the GPUs per hour, but the more efficient you make the models, the more inference you can get out of the models, or the more training you can get out of the models for the same cost. So you do have a little bit better cost control. And then for the fully private models where you own the hardware, and I've been looking a lot lately at buying my own hardware, just like for my own home data center, but even buying like consumer grade GPUs, once you start to do the math on how many of them you need, it's like, I don't know if I can, and how much heat they produce and how loud they are. Like, when you take all of that into consideration, it's like, maybe I'll just pay by the hour in the cloud. So there's also the vector database consideration, right? Beyond just the generative models, you also probably want to use an embedding model for similarity search or clustering or various other use cases. And when it comes to the vector databases, there's sort of like 3 tiers of vector databases as well. You can use something that's completely proprietary, like Pinecone or Quadrant or Chroma. When you use any of those, you get a lot more features and capabilities. Like maybe you get more than just cosine similarity search. Maybe you can also do dot matrix similarity search. You definitely get the ability to do CRUD database operations, so you can more granularly manage what data is stored in your vector embedding space. And then, sorry, they often also support metadata. So if you have document titles or tags for your documents and so on and so forth, they will allow you to do what is called a hybrid search, where you filter either before or after searching the embeddings to filter based on titles, age of the documents, tags that are associated with the documents, and this can often get better search results than just similarity search alone. Then the second tier is like somewhere in between that. The truth of the matter is, even those proprietary vector databases are almost always using something like PostgreSQL or Redis under the hood. They've just built their own engine on top of it to make it more efficient and more effective for their purposes. But you can just use Redis or PostgreSQL with an extension called pgvector. Now, all of the managed PostgreSQL databases and the major cloud providers automatically include that pgvector extension so that you can use those as vector databases natively yourself. And this is kind of like a middle ground, because if you've ever looked at the pricing on Pinecone, Chroma, or Quadrant, basically the amount of money that you pay per gigabyte of data stored in those, as well as for the network bandwidth that you use in relation to them, it can be very expensive at scale. If you only need to store a few hundred documents, or you only need to store like the memory for a user, like the managed databases can be very effective for that. But if you're trying to store hundreds of thousands or millions of documents or billions of documents, then you're talking about a situation where it's really not cost effective to use those managed databases unless you have really deep pockets and the right use case. So I see a lot of people that are using the self-managed database options because of the fact that you get most of the features that you get from using the fully managed databases, but at a fraction of the cost typically. And if you're really miserly like I am, you can actually just use a NumPy array. So like fundamentally the embedding vectors represent an array with index numbers, and then you store your data in a separate array, and once you get back the index from the embedding vector, then you just pull the same index from your data vector or from your data array, and you're able to do similarity results that way. So, and apologies, I don't know why I'm having such a hard time talking today. The build versus buy. Here's sort of the trade-offs. You'll see that there's pros and cons to each of them. I don't know, does anybody have any questions about this so far? This is sort of like my consideration set of whether you should build or buy. And mostly I have chosen to use third-party APIs and use self-managed for the database. So just tell y'all where I ended up, but any questions so far? Okay. So I think like last month, this is pretty close to where I ended. But like the whole question of, is all you're building a wrapper around ChatGPT? Because that's not really a product by itself, so to speak. Like a lot of people have built wrappers because it's pretty easy to build a wrapper. In fact, like I built a web application using Next.js and ChatGPT to do the coding that essentially mimics what ChatGPT does. But like, so ChatGPT wrote itself for me in some weird sense of that, which I was like, whoa, if I can just tell it what I want and it can build a replica of itself, that's pretty cool. But also it just shows you how low the barrier to entry is. So of course, like a wrapper around ChatGPT isn't like a novel or powerful differentiator on its own. But I really like this quote about asking the hot dog stand guy outside the Giants game what his moat is. And the reality of it is, at least from my perspective, that if your users are very happy with the solution that you have for them and it solves some need of theirs, then you probably don't have to worry about your moat that much, because user satisfaction is the #1 moat, or like the overarching moat. So some of the challenges, like I mentioned earlier, that there's knowledge gaps as well as hallucinations. There have been real world examples here of where ChatGPT gone wrong, is what I'm calling it. But basically, ChatGPT ended up getting a defamation suit because a radio jockey in Georgia was said to have been embezzling. ChatGPT just made it up, and then people ran with it, and so he's suing OpenAI now. Then a lawyer cited court cases that ChatGPT told them, and I don't know whatever happened, but they were potentially going to get disbarred over like using these fake citations. So, I mean, it's really cool when it works, but when it doesn't, it's not very cool. So hallucinations, why they happen. So the reason that hallucinations happen in part is because ChatGPT is non-deterministic, right? Like even if you enter the exact same query twice in a row, it is not going to return the exact same results, right? Like, and that means that something's going on in the under the hood that kind of doesn't follow our typical software engineering intuitions, right? Like when you do something in software engineering, you presume that it's deterministic, at least to some meaningful extent. So now we're dealing with a new type of software that is fundamentally non-deterministic. And what ChatGPT is doing is next token completion. So what is the most likely next token, or next word as some people would put it, is likely to come based on the last token that we served you. And so it's a very powerful machine learning technique, but it's still subject to error, still subject to this non-deterministic process. And then you also have to take consideration of the fact that sometimes there's poisoned or misleading data. I know I mentioned earlier how that people are looking for hallucinated packages from ChatGPT and then going out and registering those. I know for a fact that other people are essentially putting information on the internet that they know will be scraped and then inserted into these models that they know to be incorrect in certain specific ways, and then they know that the models will pick this up and have these misconceptions in them. Other times, the data is just missing. Maybe ChatGPT doesn't have access to, or should I say OpenAI doesn't have access to all of the data that you might want to use about a particular subject in making their model. Sometimes it's copyright restriction, intellectual property concerns, but in a variety of cases, it just flat out doesn't know. But what I do think is pretty self-evident at this point, and is definitely ring true with any of the model fine-tunings that I've tried to do, is that the data quality is immensely important. And it's really easy to be like, oh, I'm going to go scrape all of this data from all of these different places, and I'm going to just jam it into my own model. And I tried doing this at first. Unfortunately, what ends up happening is you have a lot of junk data. And if you don't do proper data cleansing and formatting, then you end up with really poor results. And so here is an example from an archive preprint about textbooks are all you need. And basically the gist that you can take away from this is that when things were trained only on internet data, that's the tan colored line. Whenever models were trained on internet data plus textbook data, then that's that light green line. And then when they're also trained on examples from the textbooks that are completed by an actual person, you see just this massive jump in the quality of the models. And so I don't think that this is fully expositive. Like, I definitely think there's room for ambiguity about what's happening here. This is a very limited data set to analyze. But there's lots of evidence that model quality is heavily tied to the data cleansing that goes into that. And that even models with smaller amounts of data, the same two models that have been trained on the same data, but one of the models took more effort to clean the data, and therefore the end curated set was smaller, still tend to do better than the models that have more data but more junk data. And just as an example of that, you can see here like the deduplication methods that these different models are using. You know, when you're talking about, and in some cases you are talking about trillions of tokens that these models are going through, trillions of words of data. Inevitably, a lot of that's coming off the internet. And so how that you clean that data and massage that data to prepare it prior to training makes a dramatic difference in the quality. But you'll see here that even for these organizations that are doing these, you know, multi-$100,000 or even $1 million training runs, that they have very different ways of cleaning the data. Some of them are just using 3 sentences that are the same exact between 2 documents. Okay, that's duplicate. But then, and I actually experimented with this, there's a clustering algorithm called MinHash, where essentially you can do quasi-similarity search between 2 different documents in a huge corpus of documents, and that's the technique that has kind of been superseded, this exact matching, where it does a better job of deduplication because it's doing, you know, hash matching. And then some people choose to do both, and I definitely think that there's potentially value to that. So how do you reduce or stop the hallucinations? The first and foremost way is, you'll say, retrieval augmented generation, where you have a set of data, and this is what was bugging me at the very beginning. In cybersecurity, your data needs to be up to date as of this week or last week. And then if you use ChatGPT, you know that it says, oh, our cutoff is November 2021. And it's like, well, a lot of good that does me. But you can use a vector store to ground your model, is sort of the term that I've heard used most frequently. And when you use a vector store to ground your model, what the use of that looks like is you take and you do a retrieval against data that you've scraped and stored in an embedding model, and then you inject the results from that embedding model into the context of the conversation that you're having with the generative model. So similar to the role playing that you were talking about earlier, where you tell ChatGPT you wanted to play a role, instead of playing a role, you would say, here's all of this additional context that I think is valuable to you, but you're not generating that context, the embedding model is. So a big part of the trick to making this work correctly is chunking your data properly. Obviously, you don't want to go over with a fine-tooth comb all of the different information that is that you're putting into the embedding model. You want to be able to automate that in some way. But the various strategies for breaking apart large documents, because just like generative models have a context window, so do embedding models. Like, you can only put so large of a chunk inside an embedding model. And ADA 002 from OpenAI actually is by far the longest context that I've seen that you can store in a single embedding chunk. And it's like 5 pages worth of content. But most of the embeddings are 1 to 2 paragraphs. So you have to break up, in my case, like 90, 100, 500 page PDFs into 1 or 2 paragraph chunks. And if you don't break those apart properly, then you have a really hard time with your data management and and making sure that the right context is stored in each chunk. Then, even beyond being able to chunk your data to store it and use it as context, you have to be able to label all of your metadata, or label all of your chunked data with metadata. And the way that I've actually went about this is I store a JSON header at the beginning of each chunk that includes the title, the date of publication, and tags for that chunk, so that it does a better job of embedding and returning more accurate results. And in order to do that, I had to label all of my documents. Well, that's where other machine learning algorithms come into play. So I assume everyone's heard of named entity recognition, as well as keyword extraction algorithms. So if you haven't, there are tools called, the big one is called Spacey, that I'm most familiar with. That's a Python package, and basically it's a natural it's a natural language processing package that gives you abstractions around a bunch of different algorithms that will allow you to do keyword extraction from documents, from text documents, and it's super powerful. I actually posted a couple of weeks ago on LinkedIn how that I found that no one of those algorithms really gave me the exact results that I wanted. And so what I ended up doing was taking like 5 different algorithms that are part of that package and doing keyword extraction based on each of those algorithms, and then doing a consensus algorithm on top of that, where like if I fuzzy matched 3 of the 5 algorithms all had the same keyword, then I would add it to my consolidated keyword list for that document. And that ended up providing me like really good results. And it was pretty incredible to me when I'm sitting on something like 200 million tokens worth of documents that I've scraped off the internet or done audio transcripts of. And basically in a couple of days' time, I was able to generate keywords for all of those documents and look at a few hundred of them and be like, oh, these are all really good. Like, I'm very satisfied with the results of this, and just be able to automate the whole process. Yeah.
Can you search for your, I guess, for the most relevant embedding at the same time as you search for keywords? Like, how are you doing those in parallel? Are you just pulling both results and comparing which result is better?
So there's 2 different strategies that you can use. When you're using the managed databases, they will let you do a keyword filter, and then from that filtered subset of documents, do an embedding search. Or you can do the embedding search and then filter on keywords after the fact. The way that I've chosen to do it, and I was really skeptical of this at first, but I think it's the better way of doing it personally, is that, at least in my experience, the semantic search, even though it's supposed to be very different from keyword search, right? Like where keyword search is searching for specific words in your text, and semantic search is for semantic similarity. When you put the header inside each chunk before embedding it, those tags that you had associated with that chunk get embedded along with the actual text of the chunk. So what I've done...
So it helps the embeddings?
Yeah, exactly. That's the approach that I've taken, right? And you can find on Twitter, like the guy that's responsible for Llama Index is where I first got that idea from. And at first I was like really skeptical of it. It totally makes sense if you're using ADA 002, because you have that 4 to 5 page huge chunk. And so what does it matter if you burn like a few hundred characters on the header? but I was really nervous to do it at the beginning for like these other Hugging Face embeddings models, because I was like, oh, it's going to take up a ton of the space that I have available to embed. And at least in my experience so far, it really is negligible. Like, it's definitely my preferred way to go now. Any other questions? So you label your metadata. The other part that I found is like actually really difficult about the data cleaning process is, let's say you're scraping things off the web. How do you say what the publication date of that is? Like, there are tricks that you can use, and maybe it's like in the actual text of the document, and you can pull that out through some sort of HTML scraping. But in many cases, you don't know when some document was published. And in my area, like, the relevancy has a lot to do with how recent it was. So basically, I do checks in the HTML scraping and try to pull a date out of it. And if I can't manage to pull a date out of it, I at least mark it with today's date, the date that I scraped it, so that I know over time that the older documents are going to be aged out of my embeddings. And this is what our data cleansing pipeline looks like today. So I scrape web data from different websites. I also scrape audio data. And then once I've scraped those, I have generated text, which is structured in the case of HTML. But if you're doing audio transcriptions, it's unstructured, which like actually plays a bit of a role whenever it comes time to chunk up your documents. So like, it's really straightforward to chunk based on paragraph HTML elements or like other markdown from the websites. But whenever you're trying to chunk up just like this run-on paragraph of text that was created from an audio transcription, well, how do you chunk that? There are token counting algorithms out there that you can use from either Hugging Face or from OpenAI. And so let me take a step back. One of the most challenging things in building with these tools is that you need to know how many tokens a particular query is or a particular chunk of text is, because if you don't know how long it is and you send it to an inference endpoint and it overflows the inference endpoint, you're going to get an out-of-memory error, which is a huge problem for trying to handle like edge cases in your application. So not only for inference, but also when you're trying to create these models, it's very valuable to know how many tokens a given piece of text is. Or if you're making image models, how many tokens a particular image is. And the way that you go about doing this is by analyzing using a tokenization package. Now, most of the time the models get produced and somebody will put the tokenization package out there with the model. But tokenization is not the same between each model. Every model is going to have not every model, but most models have their own tokenization mechanism and method. And so what might be 3 tokens in one model is only 1 token in another model. And so it can make a big difference in counting your tokens. But if I have access to a model and I have access to a tokenization package, what I tend to do, at least with the audio transcripts, is actually take a full sentence and then add another sentence and count the tokens, and add another sentence and count the tokens until I hit some predefined token limit that I've set inside my script, and then that will trigger it to chunk based on this number of tokens. So basically, I use a sentence transformers embeddings model called Instructor XL, which is like one of the 3 or 5 highest rated on Hugging Face for embeddings. And it has a 512 max token length for any given embedding. And so I cut off at like 450 to ensure that even with my header, I never overflow that 512 tokens. So once you got all of your documents, and you got the scrape metadata that came with those documents, then that's where I start using the natural language processing tools from Spacey and from other projects in order to generate metadata. And then once I've generated the metadata, then I chunk the documents, and then I create a vector, create vectors from the chunk documents and put them in a vector store. Beyond just the vector store though, I also store those embeddings in S3, because whether I did it myself via a, sorry, I'll give Chris a second here. So regardless of whether I am using GPUs that I host and a model off Hugging Face or a self-created model, or I'm using the APIs from OpenAI, there's a significant cost associated with creating these embedding vectors. And so the idea is that I don't want to just store those inside of a vector database, because maybe that vector database doesn't let me at scale extract all of those and take and move them to another vector database. And the unfortunate reality is today that these vector database companies are very young and their product offerings are not feature complete, and they're in heavy competition with each other, and 2 or 3 of them are going to win out and the rest of them are going to go away. So you could build up massive data sets in one of these managed databases and then just wake up one day to hear that you've got 90 days to move off of them. And,
oh, no.
And it's like, I've got to retrain the entire embeddings. And so that's something that I've used S3 as a solution for this. I just store the embeddings in S3 with the metadata as the file name in a structured file format, so that I know exactly where it came from and what it is. That gets me to talking about latency though, and this is like the thing that I think is most interesting and most relevant to everybody. People talk about technology being compute bound or it being memory bound, and the reality is that, and I agree with this wholeheartedly, is that there's another important one, which is latency bound. Like if you think about when you go out and you use web applications, when you go to websites on the internet, if something doesn't happen when you click a button within like a second or two, you're just like, I ain't got time for this. Like, so you just move on with your life. And the reality is that LLM based applications are like very prone to long fits of latency, and that's going to be the case for a while. Well, why does that happen? At least from where I'm sitting, when you're doing this, I've tried to build a web application. It's very unlikely that where you host the model is going to be on the same endpoint as your web application front end. So you're going to send as a user a request from your laptop to the web application front end. From the web application front end, they're going to send that request to a model that's hosted on a different computer. Then they're going to send that back to the web application front end, and the web application front end is going to send it to you. Now, there's some different ways that you can do this. Maybe all of your code is client-side in the user's web browser, like we're using React or something. So it is possible, but then you run into like huge complications with security and like trying to make sure that you don't give away your secret sauce, so to speak, by putting everything where the user can reverse it from their browser. So pretty much you need to have a separated front end from the model itself. and that front end serves as like an intermediary. The next consideration you have, and this is where I'll do a short demo, is let's say you want to do retrieval. If you want to do retrieval and your user doesn't put a good query in, then you're going to get bad results out of that similarity search. But there's techniques known as retrieval augmented generation, as well as another one called a hide search. And I know it's going to be kind of difficult to see this, but I can ask. So an XSS in cybersecurity is cross-site scripting. And I'm going to ask, what is an XSS? And I've offered no additional information to it. But then OpenAI is going to tell me, this is what an XSS is. And then once OpenAI tells me what an XSS is, I take OpenAI's response to my request and query the database that I have embedded based on not my original query, but what OpenAI said in response to my query. And the thing that I've found to be true, all of your query responses get returned similarity search scores from 0 to 100, or from 0 to 1. And when I was doing this just based on my request, the similarity search results would be like 0.8, 0.75. So decent, good, but after I sent my user's request to OpenAI, and this is, there's archive papers out there that, echo this experience that I had. But once I take the OpenAI response to my query and search based on that, it actually dramatically improves. Like if you could see this, it's 0.94, 0.91. So like very high similarity search results just off of using OpenAI to make me more verbose.
A question.
Yeah.
Have you found in some of your searches that if you have a topic that sort of doesn't change that much, but gets more specialized, that works? But what if something radically changed since OpenAI did their stuff? Would it still sort of point to your other?
So that's a really interesting question. I think in the case where a user had a generic request and OpenAI expanded on that, and the data in your database was different from but related to that, even if it was radically different, like you would still get good results. But if the user asks something that OpenAI doesn't have any clue about, and then OpenAI is either going to hallucinate to you or they're going to say, I don't know anything about that, like in that case, your search results are going to be terrible. So there is like sort of an asymptotic like relationship with it, where if the user is generic enough in what they ask, you probably actually get just as good of results. But if the user is not generic and they ask something that OpenAI doesn't know, you may be out of luck.
You could still just like, I guess, re-rank, right? So you query based off the query and you query based off the LLM's response, and then re-rank and whatever's best.
Absolutely. And a lot of this is predicated on how many results you return as well, and how deep your data is in general. Like re-ranking works a lot better when you're returning top K, or top number of results is like 10 or 15 or 20. Like re-ranking is very valuable, at least in my limited experience, when you're doing that. It's not as valuable when you're only returning like 1 or 3 results, and depending on how you're using OpenAI. So the example that I gave you here is I send my query to OpenAI, OpenAI responds, then I search. There's another method, the retrieval augmented method, where I send the original user's query to my similarity search and then inject these into OpenAI. 2 different use cases. I've actually went to the extreme and combined them, where I send the user's result to OpenAI, OpenAI to the search engine, then the search engine injected as context back to OpenAI just to like see if OpenAI gave me better results. And it definitely can be the case that OpenAI will give you better results, but just think about how many requests over a network I just mentioned. That's like 4 separate requests before you ever return something to the user. And so this is this solution right here, Frugal GPT, is kind of an answer in my mind to that, where like, what do you do to keep the user busy or to keep the user happy while you're waiting for this whole process to complete? Well, what you can do is send the first response from OpenAI as an ephemeral response to the user, and then overwrite that response once the full process has completed. So make it like dissolve or disappear off the screen, and the new response with the additional context be displayed instead. That's just one thought that I've had. But again, here's your whole like anatomy of how complicated this is just to do a retrieval augmented request. User to the front end to either the vector database or the OpenAI endpoint, then back to filter the search results or inject the search results as context, then back to the other one, back to the front end, back to the user. There's like 5 separate steps. Obviously, if you've ever built a web application before, this is like not desirable at all. So that brings us to like the distinction, and there's actually a great podcast from the MLOps community with, I want to say it's someone from Cohere AI, but you can listen to Demetrius, the head of the MLOps group globally, talking with someone from Cohere about like the difference between perceived latency and real latency. So I had OpenAI tell us what perceived latency is. This is actually a definition from ChatGPT. But it says, the delay a user feels or perceives between initiating an action and seeing the result on a web application. So it's not an exact measure of time, but what the subjective experience is like when using an application.
And I guess it scales with Moore's law, right? Every generation.
Yeah, like the TikTok
smaller,
generation, right? Like, I mean, first you had the YouTube generation, and now you got the TikTok generation, and I just can't wait to see what the next generation is going to be like 1 second images or whatever, and then it's just going to be done.
So do we think that the modem noise was kind of a way to make the user feel like something was happening?
That's definitely my experience.
There was always trepidation, but.
Well, and I mean, I remember waiting for like this certain sequence of modem noises when I was a kid, and if it got to that, I was like, oh, we're going to get connected. I just got to be patient. But yeah, so like definitely. And then you have real latency as well, which I think every one of us knows roughly what real latency is, right? Like when something takes more than a certain amount of time, and the answer is like typically if you have a P90, so like if 90% of your requests on a website aren't completed within 500 milliseconds, generally that's kind of the threshold or the bar that I've always heard that you're not going to be able to keep users engaged. You're not going to be able to keep users on your website. And then there are specific options that you have to reduce perceived latency. So a lot of it is about user stimulus. So like doing something to show the user that action is happening. One of the examples would be like if you ever use an iPhone, the 3 dots that come up when you're messaging with somebody in iMessages, and so they see that, oh, they're about to respond, right? Like it gives you the sense of something is happening. The next thing, and this is something that our website uses, and I think that it's a great idea for people who have like a more tightly defined use case. We know what users are coming to our website to talk about. ChatGPT, you could be asking about the weather, you could be asking for a recipe, You could ask nuclear physics questions, like you name it, they have no idea. And that's why I was saying earlier that good luck caching, because you have no idea what users are gonna ask for, and if you don't get any cache hits, then it really doesn't do you any good to cache all this information. But in our case, you know what a user is coming for, and in fact, in our website, we've actually designed it so you take a user down a question answering path, basically, where there's like a decision tree, where we're like, oh, do you want to know about offensive cybersecurity, defensive cybersecurity, governance, risk and compliance, threat intelligence? Like, we list off all these topics. And then underneath those topics are subtopics. And underneath those are potentially another layer of subtopics. And once you follow that path, you end up in a chat conversation. And from our user's perspective, that first response from the chat bot is coming from OpenAI, and it's summarizing what it knows about that information. And, but, no, we still got time. She's accounting for anyone who wants parking validation, I think. But for the caching of those responses, I'm actually sending it from our back end inside our application. So instead of incurring the cost and the latency associated with OpenAI, that initial summarized response is actually a canned response that I've either created by hand or potentially that I use GPT-4 to answer at one time and then store indefinitely. So the next option is more like the memory that we talked about. So caching all types of responses inside a vector database, and then if you hit a certain similarity threshold, because you know no two users are going to ask the question the exact same way, maybe there's a 95% similarity or a 98% similarity. Then instead of going out to the LLM generative API, you can actually retrieve from your embeddings search, and that's significantly faster. I mentioned the opportunity for doing asynchronous or cascading responses. So that's another option that you might use if you're trying to give better results, but still give the user something. That can reduce perceived latency if you serve them that initial response and then overwrite that response as a better one comes in. I don't know how many of y'all have played with GPT 3.5 versus 4, like extensively. Yeah. So I mean, you have some sense that 3.5 turbo is like way faster than 4, right? Maybe 4 is a better response, but maybe you want to serve a 3.5 response and then overwrite that with the 4 responses as the user doesn't have to wait. Then you also have model optimization or distillation, which I would argue is like a mixture of perceived and real latency improvement. It's not really one or the other. It can be a little bit of both. And then there's stream generation. So people don't realize it, but by default, these models are going to buffer the entire response from an inference and then serve you that all at one time in a chunk. Especially with the open source models, because of minor differences, you have to tweak the responses a lot in order to get a streamed response out of them. Whereas with the OpenAI endpoints, there's literally just a variable or a parameter in your API call where you set stream to true, and then you handle the output of that stream. But when you do that, you lead the user to not only perceive that it's moving, that something's happening, but you're actually getting sort of a taste of what that response is going to look like. This is...
Question.
Yeah, I had a question there. Well, I love the streamlit thing, we were talking about last time too. But what is a good latency, like, a objective for a LLM that is, I guess, generating an output, or versus one that's doing retrieval augmented generation? Like, because I'm dealing with maybe sometimes it's like a whole minute or 30 seconds when I got like 4 things together. So, like, what are you seeing as like a good benchmark for low latency goal?
So, and that's where I would ask you, time to first byte, which is like this whole notion of a streamed response, like how long until the first letters start appearing, or do you mean like how long until the full response is there?
Maybe both. Because I like, to your point, perceived latency is what's most important. Yeah.
In
so
most
what's
cases.
your time to first byte, and then what's your time for the full response?
Yeah, I mean, I'm shooting for a time to first byte of under 100 milliseconds, which I find to be pretty eminently doable depending on like how you've set it up and whether you use, like on RunPod using their GPUs, if you have the sufficient network bandwidth and you're deploying in the same cloud as your LLM endpoint, you can absolutely get under 100 milliseconds for time to first byte, even from the open source models. And definitely on all but the worst days, OpenAI is going to serve the first byte to you in less than 100 milliseconds. The problem comes in when you start talking about massive responses, right? If you're limiting the responses to 100 or 500 tokens for the max tokens on the response, then I think that you should be aiming for like sub 500 milliseconds. But to your point, like if you're getting a response that's multiple thousands of tokens, you know, the scaling on inference is quadratic. So like you actually substantially increase the amount of time that you're looking for, and it does end up being multiple seconds. And there's really no way around that, right? Like the ways around that are do what OpenAI is doing, what they already did, because if you don't, like I remember when GPT-3 was out and like it was way slower than 3.5 turbo, but what I think that they did behind the scenes with 3.5 turbo mostly was distill the model down into a smaller model with relatively the same quality of data trained for longer. And when they did that, that reduces the time to doing generation. So that's what makes 3.5 turbo so fast. And they're trying to do something similar with 4, and that's why I would argue that, like, yeah, we are seeing a somewhat of a reduction in the quality of 4, is because they're trying to serve it faster, and there's only a couple of parameters that you can play with to really serve it faster. One is the batching is definitely one way that you can serve it faster, is by distributing across multiple different GPUs the various workloads of people in such a way that you actually, so in computer science they call it branch,
With batching, does that only apply to when you train the model? Like, I don't think you can use that for.
No, you can definitely use it for inference.
You can? Okay.
Yeah, it's just exceedingly complicated from an engineering perspective, and you're not going to find any public, I have not found any public examples of how to use batching. Now, if you go on the depths of Twitter or X.com now, you will find people who are out there explaining how to do it to a limited extent, but it is possible to do batching on inference. I just can't explain the specific details of it.
With open source models, probably not with OpenAI.
Well, right, but what I'm speculating is OpenAI is already doing that on the back end. You just don't see it, right? Like they're abstracting that away from you, and they're not even telling you that they're doing it because that's part of their secret sauce, so to speak.
For the streaming, was that for GPT responses, or because that was one thing the other week I got tired of sometimes reading GPT responses, so made a iOS app with text to speech, so I could just listen to it. But that was one thing I noticed was it felt so slow, but that was because it has to generate the entire response before I see or hear anything. But I hadn't yet gone into.
Are you using 11 Labs for text-to-speech, or are you using something else?
No, it's there's like the built-in iOS
Okay, yeah.
synthesizer, and it works great. It sounds like Siri, but that's the one thing is when the responses are really long, you have to, it's essentially generating the whole thing, like without training anything, and then you get the response. But I had to figure out a way to, when you're using ChatGPT and you see like word by word, to do that. But it sounds like the streaming might be a.
So the way that, and I'm still fiddling with this, I haven't quite got it working like I want it to, but basically part of the problem that you're running into most likely is that you don't have the ability, the granularity to tinker too much on iOS with like how that data gets sent from the text-to-speech portion. But the way that I have it set up is there's a company called 11 Labs that offers a text-to-speech API, and you can use it to model your voice, or you can use it to model a bunch of other people's voices. And so basically the clone GPT wrapper that I built, it streams a response from OpenAI, and as each chunk of the response gets streamed back, it automatically sends that to 11 Labs, and 11 Labs sends back that chunk as a stream. The problem with that is each chunk from the stream isn't necessarily whole words. And so like, if you don't have some sophisticated way of handling that, it can sound like gobbledygook, for lack of a better term. Like, it just doesn't come out right. But it is possible. It is possible to like speed that up. I'm just not that great of a TypeScript developer, which is like if you were doing it in Python, it would probably be a lot easier, honestly. But yeah, so that's sort of the answer that I would give you. And I agree that like it's very slow if you have to wait for the full response to buffer, right? Like, to your point, it's like 3 or 4 seconds sometimes if you're waiting for a very large response.
I guess it depends on the use case, right? If you're looking at code, then you want to see everything and you'll skip around and look at it. But if you're actually asking something very detailed, you're going to read every single word, and so that sort of helps you. And I would think with your use case, you're not going to skip around.
No,
you're going to be very sort of intent,
linear.
and so you could stream it then.
Yeah, and that's the goal on my side. Is like a lot of my people are students, and to your point, like, who wants to sit there and wait for all this to show up? On top of that, who wants to read tons of text, right? It's much better if you have something, if you're using it as a tutor or something, to have it talk to you. And actually, I've written a Python script that goes from, you can take your speech to the microphone in your computer, translate that to text with Whisper, which is a speech-to-text endpoint from OpenAI, send that to OpenAI ChatGPT endpoints, get a response back, and then like the whole conversation round trip is conversational, like it's speech to speech. So that to me is like the ultimate end goal, but I mean that's a lot of engineering, and there's a ton of latency in at least my personal solution to that. And that's true even if like, so OpenAI hosts a version of Whisper, and even when you use their version via the API, like you can run Whisper locally. So you can't, and the way I have it set up is to run Whisper locally, then send to ChatGPT, then send to 11 Labs and get the response back. But even when you run the much faster version of Whisper via their API, it's still like 10, 15 second round trip at a minimum. And that's not really conversational, right? Because as soon as it sounds so ideal to have like this conversational approach to it, but then as soon as you get it built and you realize how slow it is, it doesn't feel conversational. So like, even though it is like superior, it's not the same as having somebody to have a conversation with. You're sitting around waiting forever for you're like, Today, come on. But, so here are some of the different like things where I sort of have plotted out. This is not scientific at all. This is just my impression in working with these tools about like what are the x-axis is, the x-axis is engineering difficulty, and then the y-axis is perceived latency improvement. And I think that it's pretty simple to implement user stimulus, like 3 dots appearing in the chat. That's like, 15 minutes of front end work for somebody. Basic response caching like we've done, it does require substantially more work, especially when you have a front end and a back end to your application. It's not all, you don't want to store the basic response caches in the front end. You want to have some difficulty. There's no moat to that, so to speak, but definitely if you make it really easy for your competitors to steal all of your front end or all of your basic cache information, then that advantage just disappears overnight. And it's a decent amount of work to implement, so why not put it in the back end? And if you store it in the back end versus the front end, it's a lot more work. Vectorized response caching, this is even more effort, but the payoff is probably better if your use case supports it. Streamed responses are super simple to implement. And, if you're using an API, it's literally just an extra parameter. But the advantage to that, I think, is pretty substantial, right? If you've ever played with one of these and you have not set it to stream the response, it's a much worse user experience than if you do stream the response. Then you have asynchronous or cascading responses. I think this takes actually a lot of engineering difficulty. I probably have that a little bit too far to the left. But the improvement would be huge, right? Like if you're giving the user a taste of a response and then feeding them a much better response after a few seconds, if you haven't lost their attention and they haven't moved on to the next idea, that can be a huge improvement. Model optimization. So where I say that model optimization is a reduction of perceived latency is in relation to batching responses and things like that. I guess technically it's also a real latency improvement, but I would sort of reserve the real latency improvement for distilling the models, because I think distilling the models has a bigger impact on the real latency. As far as reducing the real latency, there are some pretty straightforward ways to do this. Network bandwidth and co-location of your application components is a key aspect of this. If your vector database is in one cloud in one region and your front end to your application is in another cloud in another region, and your LLM for generation is in yet another one, that's going to automatically make your application much slower. Then you also have vector store infrastructure and ensuring that that's right size for your application. If it's too small and not properly configured, then you're going to run out of space really quickly. If it's not properly configured but it's plenty big, you're also not going to, basically if you don't index your data, you're going to end up in a situation where the retrievals are much slower. Then you can just throw more compute at it, right? Like if you're OpenAI or somebody like that and you have access to tens of thousands or hundreds of thousands of GPUs and you need to, you can just throw more GPUs at it. And then as new model architectures come out, that's probably going to be what provides the biggest improvement. But here's a brief chart of where I think that the advantages fall as far as reducing real latency. And I think it's pretty simple to implement the first one, right? Just make sure that all of your application components same cloud, same region. That makes a pretty substantial difference with minimal effort. So the last thing is the user experience, and I actually think that this is where like a huge part of the advantage is. So this guy is Abraham Joshua Heschel. He's one of my favorite philosophers. My undergraduate degree is in philosophy, so this is very much where my interests lie. But he tells this story about going to Grand Central Station back in the 1960s, and this is the information desk at Grand Central Station. So like imagine going there and being able to ask any question about what's going on in Grand Central Station. And he tells a story about like, what if you go to the information desk at Grand Central Station and you ask them, what do you know? That's not really the right question to ask when you go to the information desk, right? Like you should have some sort of idea of what you're looking to know. And something that I experienced really early on in doing like user feedback from ChatGPT is I showed a family friend ChatGPT and I was like, you gotta check this out, it's amazing. And the first question she asked was like, what's the weather today in Houston? And I'm like, I mean, you're not gonna be satisfied with the result and it's not really what it was meant for. Like, this isn't gonna work out well. I'm not gonna sell you on this. But I think there are like 3 specific ways that you can take into account this problem about what do you know. So there's meta prompting, which I'll go into that here in a second. There's follow-up questions, and then there's single prompt workflows versus developing a game, so to speak. So meta prompting is like the user asks the question, what is the first step to containing malware? Like, so if you get malware on your system in cybersecurity, that's a problem. Lots of people in cybersecurity are responsible for knowing what to do when that happens. Well, a meta prompt would be like saying to the API endpoint, you're a cybersecurity engineer specialized in configuration hardening and computer networks and system. Let's think through this step by step to ensure a correct answer. And then the user question, what is the first step to containing malware? So when you do that, in my experience using the API, you get a substantially better result. And this, funny enough, is where the custom instructions. So I said one of the 2 things since last month that's changed. In OpenAI, you go to settings and it asks you, what would you like ChatGPT to know about you to provide better responses? And then the second question is, how would you like ChatGPT to respond? What I would tell you is happening underneath the hood is that the system prompt, so you have system prompt, assistant prompt, and user prompt. And all of those get concatenated together in an array to form the actual thing that ChatGPT is doing next token prediction on. The customization questions or the custom instructions that ChatGPT is talking about, I would submit to you that I think those are going into the system prompt. And so all of this extra information about you is automatically started as part, or it's automatically a part of the conversation before you ever start. And here's an example that I used of like how the response works. You'll notice when I just asked from the perspective of the user, a much shorter response. If you were to read it very closely, it's actually a much better response down here in the second example. Both of them the exact same question. One of them just also contains a system prompt that's helping jog ChatGPT's memory. The next one, and this is also something that ChatGPT has implemented in the last month, but Quora, the internet social media site, they have their own chatbot that's based on different APIs, and they had already implemented this a couple of months back, where you say something to ChatGPT and it comes up with what are the next questions you're most likely to ask. And that's a pretty obvious improvement on the user, because if you notice when people are typing, they get tired of typing. And a lot of people actually go away from the conversation because of the fact that they're just exhausted mentally from having to come up with the next question to ask or the right way to say it to get the right response. But you can actually, in the left-hand side, I did this locally on my machine, but by using the correct type of system prompt, you can actually get it, instead of answering your questions, to give you 5 examples or 3 examples of what are the next questions this user is likely to ask based on what their last question was. And the final thing that I'll talk about really briefly is I think that there's like 3 different parts of the experience that a user has. At least this is reflective of what my experience has been like. There's an early game, whereas like the chit chat or the getting to know ChatGPT, so to speak, like every time you enter into a conversation with it, you're starting out typically with some sort of generalized topic. You know, what can you tell me about this topic? And then as you move further into the conversation, you know, it's like chess where certain pieces get taken off the board, other things get moved around, and the style of the conversation has changed in substance because of the way that the conversation is flowing with ChatGPT. So maybe you're asking for specific things. And then in the end game, most of the pieces are off the board and really important things are happening. So to make this concrete, like if I'm asking ChatGPT for a piece of code, I'll say I need to create this page I need to create this page component of code written in TypeScript for Next.js. Here's the type of web page and website that I'm creating. ChatGPT will spit something out. And I'll say, well, that's good, but I'd like you to make these changes. And then ChatGPT will make the changes. And I'll think, oh, that's roughly correct. That's sort of the middle game that I'm talking about, where you've gotten down to a specific ask. And then once I take that specific ask and try to run the code, and it either works or it doesn't work, I'm going to come back to ChatGPT and I'm going to say, yeah, that was roughly correct, but this, and this are still not right. Here's the error messages I'm getting, or here's this, that, and the other that I'm getting. I think each of these 3 phases of the conversation warrant different types of system messages and warrant different types of embedding information. And so when you are building applications and you have highly specified use cases that you're building for, you actually have the ability to enrich and inject a lot of information at the different modes or the different parts of the conversation that will get much better results. So that's my talk. That's what I've been learning about for the last couple of months with ChatGPT. Any questions from anybody? I know we're running sort of close on time, but happy to answer any questions y'all do have or talk about anything else y'all want to talk about. Yeah.
For the cascading system that you mentioned, is that just referencing like ensemble system of different models, or?
So the way that the cascading, the only way I've seen it implemented so far is that it would use GPT 3.5 Turbo, for example, to give an initial result. And you know how you click the regenerate response button? Instead of sending it back to GPT 3.5 and taking a different response, it would send it to GPT 3 or to GPT 4, and therefore give you what is theoretically a better response, but at higher cost and longer latency. But the ensemble model that you're describing is what a lot of people speculate that's actually happening in GPT-4 in the back end, right? Is that it's actually an ensemble of a bunch of different models, and they do prediction. Like in computer science, you have branch prediction in CPUs, where in order to make computers faster and faster today, they actually have more compute your computer has more compute than you're ever using, and it's using the additional compute to calculate what it thinks the next piece of code is going to be to run. And so my understanding of how the ensemble models work is that multiple different attention heads on the back end model are sending tokens, and you get to a consensus between multiple ones of those, and it will prefer those tokens over the rest and send you back a response based on that.
Well, but less about like the mixture of experts is like the system that GPT-4 uses, but more on the latency side as far as when someone prompts it, but just looking at the paper, which is, I'm glad you pointed this out because this is something I've thought about as far as when you send a prompt, the system here mentions it initially sends the prompt to GPT-J for the fastest response, but then if the response is below some threshold as far as what you expect, it then sends the prompt to GPT-3, and then if that answer is acceptable, that's what you get. If it's still not, if it's still below the threshold, then it sends it to GPT-4. But it shows that for that system, you have a threshold that you can spend or set, which for open source models, you do get the likelihood with the responses, but for GPT, they don't provide that.
They did originally, and then they stopped doing it, and they're supposed to start doing it again in the fall, allegedly. So, like, yeah, that's the problem with it, right? Is like you don't always have the inspectability of being able to say what the similarity score was, and therefore whether or not it meets some acceptable threshold, which means you fall back to relying on user feedback.
Yeah, and I guess that it makes sense if you're using open source models, because you can just have a model of 3 different sizes, and the smallest one that's the fastest, if it can provide something that's at a high likelihood, you get the response, but if it's a low likelihood, you get the medium model, and if it still can't provide something, you go with the big slow one.
Yeah, and not just slow, but expensive, right? Like, because it takes up, I mean, it's incredible how fast I burn through my credits on RunPod or one of it. Like, I mean, it's crazy. Like, it's legit. And I'm a single user, right? Like, if I'm a single user in a Jupyter notebook and it's costing me $2 or $3 an hour, that doesn't sound like much, but over the course of a month, that's a few hundred or a couple $1,000s, and I'm a single user. And like scaling that to a large user base is very problematic today.
Yeah, that's actually what my next question was going to be as far as your experience with RunPod, because I've been using Lambda for the past few months, but their on-demand instances are almost
gone.
They're non-existent. I've been checking for the past like 10 days, and
people have
2
written
days.
automations already.
Yeah, I saw that where they just automatically pick it up as soon as something becomes available. So I started looking at other providers, but I haven't. Lambda was just it was so convenient as far as what they offer, both the notebook and then.
RunPod's very similar. It works almost exactly the same, and I found it to be like really useful. The only thing is, I think they're gonna basically, as soon as one of these startups gets known, the capacity gets chewed through. Like I really think that we're gonna probably see an even bigger crunch in like Q3, Q4 of this year, like where there is no more bandwidth. I guess we're already in Q3, but like as Q3 wraps up and we hit Q4, there's not going to be any more of these GPUs for like average people, because large companies are going in and scooping up big blocks and making long-term commitments. Like that's the other problem with Lambda is a lot of people make like 3-year commitments to them, and they get first priority on it all, and so all of the on-demand instances get chewed through.
Yeah, I mean, making a 3-year commitment on A100s or H100s is crazy, because in a year from now, that might be like the second, third, fourth best GPU.
Oh, it already is today, right? There's a new Grace Hopper GH100 that is like either out or will be out within 60
The
days.
GH200, I think, is that the one?
I don't remember if it's 100 or 200. You may
The
know
new
more than I
one.
do. But yeah,
Yeah.
there's a new one that's already out that has more bandwidth. So it's crazy.
The, just for the verification, the parking stuff, you can just go and talk to Emily and
Awesome.
she'll do it.
Perfect.
Yes. We've got about 2 minutes.
Yeah.
right?
Any other questions before we head out, y'all?
Yeah, I was gonna ask representation, by the way.
Thank you.
For the latency requirements and bottlenecks. So I know with LLMs today there's two camps, right? There's the chatbots and conversational specific tasks, and there's also the, I guess I'll call it digital assistant task, where you can sort of build an application, incorporate them.
Agents.
Agents, yes,
Yeah.
pretty much. Have you seen any difference with latency between both applications, or they're usually roughly the same?
Well, so I would say the chatbots are like much lower latency and much more straightforward. Not for a single call, right? Like not for a single API call or for a single response or for a single generation. But the agent type systems are trying to chain together many responses. And so you end up with like, oh, it takes 10 minutes for it to reason through. Like chain of thought is one of the common techniques from lane chain. And whenever you do that, you may be waiting for 30 or 40. You can see the intermediate steps happening, but to get your end response, you're waiting for longer. And the other problem I see with the agentic systems today is GPT-4 is really the only tool that is feasible to use for that sort of thing, because you get a compounding of errors over a number of responses. So if only 10% of response one is bad, but then it asks a second question of itself before giving you the final response. Like every intermediate step you add, 10% latent or 10% error rate ends up compounding to where you're only like 20 or 30% likely to get the correct end result today. So it can be a dramatic reduction in the accuracy of the models. But I think as time goes on, people are solving a lot for that with open source models that are like task specific, and then they distribute the chain of thought between task specific bots, where maybe you're using GPT-4 for the main thread of the agent, but then using like task specific agents and letting GPT-4 pick which one to use as it's assembling the final response, if that makes sense. Absolutely. Well, thank you all for coming out. Like I said, next month we've got a sponsor, so any requests as far as food or beverages?
We need a pizza, you think?
I was thinking, I mean, that's always a
Yeah.
simple one, right? So
Yeah.
come hungry next time, for
Yeah.
sure. It's on Fennel AI. But anyway, thank you all for coming. I highly encourage all of y'all, if y'all are super interested in this, join the MLOps Slack. There's tons of people on there and there's tons of conversations happening. It would be great if everybody was on there and we could chat on there. So you can just go to the MLOps. Huh?
How do we join that?
Yeah, MLOps community, just type that into Google and it'll pull up their website, and when you click on newsletter, I think, it will take you to the join page. You enter your email address and it'll send all the information to you via email. So yeah, it's awesome. I love it. Every day people are talking about these problems on there, so, and there are much smarter people on there than me. So
Thanks, Wes, that was awesome.
Thank you.
Chris. What was it? Emmanuel? How you doing?
No.
Did you? You did? From where?
I'm feeling better.
Where?
Yeah.
Is that in the Caribbean?
Well, we